Okay, if you're watching this video, you've decided to attempt the Excel graphing homework at home, and you probably need a bit of extra help in creating these graphs to the standards that we want in the science department. Now then, I'm using Office 2010, and so this is Excel 2010. If you're using Office 2013, then your version of Excel looks slightly snazzier than this. And it will be a slightly different layout. If there's anything that I do which you can't find, there's always this help menu up here, okay, which if you click on it, yours will obviously be in a different place. You can type in questions into here. Just type them in using keywords that I use in the explanation, or writing a sentence which uses that keyword, and you should be able to find what you're looking for and where it is in your version of Excel. Okay, let's get started. The first graph that we've got is a volume and temperature graph to plot. So here's our table of data with the volumes in it, and here's our temperature column. Okay, let's have a quick look at the instructions. So to plot the volume on the y-axis and the temperature on the x-axis, and then using only the graph, we need to find the volume of the gas at 0 degrees centigrade and the volume of the gas at 150 degrees centigrade. Now we need to use the graph to do this, because you can see that our temperature only goes as low as 25 and only goes as high as 100, and so this highlights one way that we can use graphs to make predictions from data that we've got about data points that we didn't collect for, or we can't possibly collect for because of the limitations in the classroom. Okay, so first thing is to highlight the data. I leave out the headings. Some people include them, but I find that sometimes it goes wrong. Go to Insert along the tabs at the top here, and then this menu ribbon changes, and we're going to select a scatter graph, and it's the very first one in the top left corner for me. If yours, if it's slightly different, it's the one with all the points and no lines connecting them. So there's our graph. Okay, I'll make that a little bit bigger so we can see it a bit more clearly. And also make the data a little bit bigger as well. Okay, now then, if we look at that graph, it doesn't look great, does it, at the moment, but it will look better in a minute. But first of all, let's just check that the data is in the right place. So on here we've got a scale from 0 to 120, and on the y-axis that should be volume. Well, our volume only goes from 11.2 to 14, so I think that must be the temperature. And then on the x-axis here we've got the volume, which should be the temperature down here. So I need to swap the axes around, or swap the data around the way that's been plotted by Excel. To do that, with design highlighted here in the menu tabs, click select data, and then series 1 and edit. Okay, and we get this new menu appear. I'm going to leave the series name blank because we've only got one set of data on our graph, so we don't need to identify it from different sets of data by giving it a name. I'm going to look at the X values. By clicking on this, it highlights them and shows me what has actually been plotted as an X value. So I want the temperature, so I highlight the temperature and click again on this icon, and you can see the data has changed here. And then I'm going to do exactly the same for the Y data, and click on the icon, and there we go. So now we've plotted our data the right way around, with our volume on the y-axis and the temperature along the x-axis. Click OK, and then OK again. Right, to make life a bit easier, I'm going to move the chart to a new location. So again, on the Design tab, Move Chart, I'm going to move it to a new sheet, and I'm just going to call that V and T chart, so it's easy to find. And click OK, and there we go, and it's moved along to its own page. Alright then, I need to add some grid lines. So again, on the Design tab, we've got this Charts Layout section here. If I click on this down arrow, it gives me more options, and in the bottom left hand corner I've got the most detailed option, and so I'm going to select that one, and that's going to input a good selection of grid lines, major and minor for me, and also places to put in the axis title. I'm actually going to get rid of this label for series 1 now because that is not needed, so that's just a left click and delete or backspace. And I'm going to put a title on the graph, so go to layout and then chart title and centered overlay, and I always start off with a graph to show. And our two variables were volume and temperature, and we were looking at how the volume of gas changes with the temperature, so a graph to show how the volume of gas changes with temperature. It says exactly what it is. Okay, so there's our title. And we've got pretty much the basic level of detail that we need there to get the lowest possible marks if a graph is in our lab report and it's being assessed by the teacher. At this point, if you're working with the Excel document in front of you, or you've got it on your computer, you may want to pause this and do what I've done, and then you can carry on after you've got to this stage. I'm just going to carry right on. The next thing I'm going to do is label the axes, so I'm going to click here and highlight the contents, and if you remember, this was volume. Okay, so I'll type in the label there exactly as it appears in my heading on my table, and I'm also going to put in the uncertainty here and the units. If we go back, you'll see that the data for volume is recorded to plus or minus 0.2 of a centimetre cubed. So I'm going to insert in there, I'm going to insert a symbol for plus or minus, and because I use this quite a lot, it's on this ribbon at the bottom here already. There it is. If you haven't used it before, then it probably won't be here, so you just have to search through these options until you find it. Okay, or you can use this character code. So there it is. It's found in Calibri font and in IPA extensions, if you want to have a look for it in there. So I'm going to insert that and then close it, and you can see it's appeared there, and the uncertainty was 0.2, and then the units are centimeters cubed. Now again, let's just zoom in on that a little bit. You can see that the 3 here is not raised up as a power would be, so I'm going to highlight that like so, and then I'm going to go to home here and then font, and in the bottom corner there's a little down arrow, diagonal down arrow, which if I click on it gives me some extra options, and I'm going to click on superscript and then click OK, and now that's raised that up as centimeters cubed. I'm doing exactly the same with the x-axis, so that was temperature, and again I'm going to insert the symbol for the uncertainty, plus or minus. There we go. And while I'm here, I'm going to insert the symbol for degrees as well, which is this one. Okay, there's the character code for it, and that's where you'll find it in this lot of symbols. So I'm going to insert that as well, and that's going to save me having to do that step all over again in a minute. And that was plus or minus 1 of a degree C. Now the degree's already in there, so I just go past it and put in the capital C for degrees centigrade. Okay, so now my chart is looking a lot better because now I've got axes on there, labeled axes. I'm going to add some extra detail to these axes. You can see at the moment I've just got tick marks for the major points. I actually want tick marks for the minor grid lines as well. Okay, these divisions in between the major ones. So left click on one of the numbers. If I don't left click on one of the numbers, it doesn't do anything except give me a different chart area format box. So left click on the number, right click and get format axis. Here I'm going to put on tick marks outside, and I'm also going to make the axis bolder so it stands out. So go down to line style, and where it says width, and I'll put that up to about 1.75 or 2, and close that, and that's that one done. And then I'm going to do exactly the same on the x-axis. Left click on a number, right click, format axis, and then outside I'm going to put some minor tick marks, and then line style, and put that up to 2 again. Okay, so again, that's looking pretty good. Now I need to look at the size of my axes and see, is my data spread out well? Well, it's not. And if you remember from the instructions, we also need to take some measurements. We need to find the volume of the gas at 0 degrees centigrade and the volume of the gas at 150. At the moment, I can't find the volume of the gas at 150 because my scale only goes up to 120. 0 is fine down here, so I can leave that where it is. Also, all of this space here is wasted, and it would be far better if I could spread out the data on the whole of the graph to make it clearer to identify a pattern. So I need to have my y-axis. I need to have my y-axis starting at around about 10, so I'm going to shorten that. So if I left click on a number, right click again, and go to format axis, and then here I've got axis options. Minimum I'm going to keep as 0, maximum I'm going to change, sorry, I beg your pardon, minimum I'm going to change to 10, and maximum I'm going to change that to about 17. Now I know from experience that I need my axis to be a little bit longer to take that measurement at 150, but you may need to fiddle about with it when you're doing your own graphs. I'm also going to change the major unit gradations and the minor unit gradations. So I'm going to change this one to 1, and I'm going to change this one to 0.2. And generally we halve the values that Excel decides to put in there for us. That works pretty well as a rule of thumb, but you may need to fiddle about with that a bit to get a nice looking graph. So I'm going to do the same with the x-axis. I'm going to keep this at 0 this time. I'm going to change this to, well, I need to take a reading at 150, so I'm going to change it to 160, just going beyond where I want to take the reading. And I'm going to change this to 10, again halving the values that Excel has chosen for me, and we'll see how that looks. Okay, let's close that. Now that looks pretty good. These are more rectangular than square, so I'm not really very happy with that. I'm just going to go back to format axis, and by fiddling around with these values, it's possible that I can get these to be a bit more spread out, or sorry, square looking rather than it won't go down that low. Okay, so let's try it to 0.1 and see what it does. Okay, that's not really of a major importance. It's okay at the moment. Right, now then, if you want to do up to this point, okay, carry on with your own graph, then take a break around about now and do what I've done. If you're ready to continue, then let's go to the final part, okay, which is adding error bars and trend lines and getting our data from the graph. So I'm going to change these diamonds that Excel has chosen for me, and I'm going to change those to crosses. So left click on one of the diamonds, right click using this drop down menu, click format data series, and I'm going to go to marker options and then built in and X, and I'm going to make those a little bit bigger as well, so stand out a little bit more, and I'm also going to make them a little bit heavier, so using marker line style I'm change that to 1.25. that should be enough. Okay, so they stand out a little bit more. I'm also going to add to that some error bars. Okay, so remember we've recorded, or somebody's recorded uncertainties on our data, okay, plus or minus 0.2 and plus or minus 1 for temperature, and I can use that to decide how good each piece of data is when I put on my line of best fit by adding error bars. So I'm going to click on error bars, and this is now in the layout section of the tabs, or the menu ribbon, and I'm going to click standard error bars, okay, and they're much too big, they're not the right size errors. So clicking on the horizontal ones first, left click to highlight them all, right click to get a drop down menu, then format error bars, and then I'm going to go to fixed value, and the error on the x-axis is 1, so I'm going to type 1 in there for fixed value, and then on the vertical bars, again click on one of them, left click, right click, format error bars, and this time fixed value of 0.2, and close that. There we go. Okay, so now I've got correctly formatted error bars, and I can put in a trend line. So again, with the layout tab, go along the menu ribbon to shapes and select straight line, and then anywhere on there just put in a straight line. That's not quite in the right place at the moment, so let's try and get it a bit more how we want it. Remember that we need to be taking a reading at 150 degrees, so that line has to be quite long. But the part that I'm interested in at the moment is around here. What I'm trying to do, or what I'm going to be trying to do in a second, is moving this line around so as many of the points, or the error bars attached to the points, run through the line. At the moment you can see there's 1, 2, 3, 4 data points which do not touch, or their error bars do not touch the line of best fit, and so I think I can move this around a little bit more to include some of those data points. So if I pull this end down so that it's just touching the error bar of the first point, and then I move this end down a little bit, okay, like so, then I'm incorporating a few more of those points like so, okay, and that's just about including all of the points. I've still got one here which is clearly not touching this line, and this one here, well, the rectangle that is prescribed by these error bars could be said to be just touching that line, but it's debatable. What I'm going to do is I'm going to identify those 2 points as anomalies now, because they don't fit the line of best fit, or the trend line. So I'm going to choose a elliptical or circular shape. If I hold down Shift before I left click and start drawing my circle, I get a perfect circle no matter what I do with my cursor. Okay, if I let go of Shift, then it will allow me to do an ellipse. Okay, so I want a circle of about the same size as the data point with the error bars. I'm going to get rid of the fill from there. The weight of the line is pretty good, so I'm just going to move that and put it over that point. It's a bit debatable whether the other one is on the line or not, but I'm going to err on the side of caution here and say that it isn't, and circle that one as an anomaly. Okay, so I've identified the 2 anomalies. I'm just going to make this line a little bit bolder by formatting the object. And there we go, so it stands out a little bit more. Okay, right, now that's pretty much done. Here you can see at 0 degrees our reading for volume is around about 10.1 centimeters cubed, and the reading for 150, well, it's difficult to kind of read up and go across and say exactly where it is. It's between about 15.5 and 16, but exactly where is not easy, so I'm going to make life easier for me and for the teacher who marks this, and I'm going to put on here a line going up to this one like that. Okay, just going to make that a little bit bolder. Okay, and I'm going to insert a second line going across from here to the y-axis. Okay, like so, and again I'm going to make that a little bit bolder, and that's going to show quite clearly what the volume is at 150 degrees C. Okay, we can see from that it's 15.1, 2, 3, 4, 5, 6, 15.6 centimeters cubed, plus or minus 0.2 of a centimeter cubed. And that really is how we format a graph in science and take readings from our graph of data. Okay, thanks very much for watching.